Hi everyone. Yeah, so I'm currently at ASOS. I'm a contractor. I've been jumping around quite a bit, and consequently I've worked on quite a lot of data lakes. Some good, some a lot not so good. And so I guess what I'm going to try and talk about quickly in the first half, maybe the first 15 minutes, is what is a data lake and can you actually build it in an agile way? From the previous talk, I noticed he was talking about the horizontal aspect of data engineering, and this is like very important and very real. And part of that makes it difficult to be agile because you're sort of working across an entire organization. So yeah, hopefully I will explore that. Do I press the clicker now? Yeah. No? Okay. Yeah, I'll jump around a lot. And please interrupt and ask questions, so I know which slides to focus on, because I won't be covering all the slides. So I guess try and give a definition. What is a data lake? Has anyone read this book? Or got it, at least, on their shelf?
It's very long.
Yeah, so if you skip right to the end, you get to the definition of a data lake. I'm not going to read that out. So I'm gonna. There's another version by another Martin. So yeah, this is Martin Kleppmann. Martin Fowler, you should have heard of him. He's one of the founders of the Agile Manifesto. It's slightly shorter. It's a single store for all of the raw data that anyone in an organization might need to analyze. Okay. So how does that differ from a data warehouse or something? Well, the distinction is that the data stores raw data in whatever form the data sources provides. No, not necessarily in assumptions about the schema, again, following on from the previous talk. Each data source can use whatever schema it likes. And it's up to the consumers. You push the problem further down. Some other things in this particular link, which is a really good read, is he says that data is often immutable. And you have schema on read or schemaless, and storage is oriented around large schemaless structures, HDFS, S3, which is mentioned, and then Azure has ADLS Gen 2. And here's a diagram which I pinched off his website. Similar, again, so yeah, data warehouse, you have a lot of processing. That's what that I blob I think is supposed to mean. So you have a lot of processing up front in terms of understanding the data, turning it into a pretty schema. And then people consume the processed thing. Data lake, you can just sort of dump data indiscriminately in it. And then it's often up to different consumers and different use cases to understand the data. This is like, I guess, a diagram. This is pinched from his website again. This is a good sort of architecture or organizational structure for a data lake, where you'd have a few individuals' interactions going on, the data scientists and the engineers, data engineers. This slide, I think, was before data engineers was a big thing, so I just added that. They investigate the data lake, they understand it. And notice that there's a small number of them, okay? And then you have the masses, and once these guys figure out what the data is, potentially some reasonable, sensible ways of hitting more than one use case at a time, then what these things are called lakeshore marts will evolve. Now, yeah, the bad, what you often sometimes see is, especially in big corporations, is they'll slap on some massive tools and try and put a lot of centralization and process and get rid of all the developers, get rid of all the data scientists, because they're too expensive and they like coding and stuff like that. So that always goes terribly wrong. So yeah, again, trying to give you some high-level information. I know the second half of this talk is going to be doing a technical deep dive, and I'm going to try and give a history of Spark. But I want to get around some of these concepts and problems you'll see in data lakes, because as engineers, often we're the only people who actually understand these problems. And it's up to us really to communicate that to the rest of the business and to ensure that these mistakes are not made. So some of the mistakes you will see are, I define good to be relatively cheap. Business value, my sample size is very small based on my experience. But yeah, anyway, I'll carry on. The cost low, business value weeks to months is what you'd expect from an Agile project. Bad often takes many years before you get any business value. Some of the good things, schema and read. Some of the bad things, meta stores, I'll talk about that in a bit. Using platform as a service, things like EMR on AWS, really good. HD Insights, Dataproc, very easy to spin up. Using on-prem clusters, not so good. Very expensive to set up. Good. Scala Java apps, JVM apps. Most of this big data stuff is JVM ecosystem. And trying to keep it lightweight, not trying to get in some big tools and heavyweight processors. And try and get flat agile teams. Again, trying to use agile or extreme programming principles like KISS and Yagni, as opposed to big upfront design. And try to focus on one business problem at a time. That's, I guess, the main thing. Solve one business problem. So some vertical end-to-end side. Let's skip ahead. So you might have some sources at the top, consumers at the bottom. Try and get a vertical slice. Try and build a vertical slice solving one end-to-end business problem first. Don't necessarily try to solve all the business problems in one go. Just get one or two working, and then once you've got one or two working, then dry the code up. Just deduplicate the code and refactor it in a normal way. Rather than trying to jump to some solution that's going to fit every case. And so again, this diagram is emphasizing the importance of the raw layer. Just get some data in there and give it to the consumers. Maybe they can actually deal with raw data. I mean, a lot of data scientists can. Some analysts will be able to. If you're lucky, it could come in a good format like Parquet. But generally, and you'll get a lot of value out of that. Got a lot of value out of that because of the speed at which you're doing it and being able to surface this data to all these people who've not seen it before. But you might need to also transform it. Another thing you might need to do is get rid of any restricted data or mask restricted data. So this is a very common thing you have to do. You want to do that via some kind of service that tokenizes things that you'd be able to reverse the lookup. It's got to have satisfy lots of properties like key rotation, and it can't have collisions. It has to be two-way, things like that. Solve those problems. And then, it'd be nice if you get the data all into Parquet. So I've got two things going on this slide. I've got the vertical cylinders and the sideways cylinders. Vertical ones representing batch jobs, sideways representing like Kafka, if you're to do a streaming architecture, because it is something that people are doing, but not very many people actually need the Kafka, but it does have some benefits. Anyway, so generally you'd have Avro if you're using Kafka, and generally use Parquet if you're on batch mode, so if you're on file system. And then over here you start doing more stuff to it. You start joining it, flattening it, doing some transformations. And typically the reason why you're doing this is because some analyst doesn't want to do this himself or doesn't know how to do it himself, or you're trying to duplicate. And be careful of going any further than this. Like, sometimes you'll see systems that claim to sort of turn this into a database or a data warehouse, and that's not what a data lake is. So, for example, Hive and Impala, I mean, these technologies are quite impressive and they can do some impressive things, but ultimately, if they're trying to do, say, ACID transactions or something like that, why don't you just use a database? That's not the point of a data lake. It's not that it's a wrong thing to do, it's just not for a data lake. If you mix those two concepts together, you're going to waste a lot of time and a lot of money. Because yeah, you're essentially re-implementing a database on top of a file system, but a weird file system. HDFS and S3 are very weird. S3 is not really a file system. So yeah, you don't want to do that. So anyway, so here's some principles. Try and follow these principles. Immutability is very important, especially for data scientists, because they want to reproduce results. If they run a query today and then you overwrite some data or you append some data to some data set and they run a query tomorrow and it's got a different result, it's going to make it hard to do their job. Yeah, one thing you see a lot of, which is quite annoying, is people thinking that they're reading individual files, but the input will be an entire directory because files have to be split up because the data's so big. You want an easy way to identify when new data arrives, so the simplest way of doing this is just partition. At the very top of your architecture, you just partition by the landed date or the process date, and then you repartition it later on. Yeah, so repartition it over here, don't bother repartitioning it over there. Yeah, Parquet has headers, and if you have a good directory structure, that should tell you a lot of stuff about the data. Now, you will see a lot of these big tools trying to invade upon your lake, claiming to magically tell you about what your data is. I'd suggest be careful of them and focus on just the simple things like Parquet headers have a schema, add some lineage fields to your data if you need to, have an internal open source within your company, so try and encourage other developers to look at your code and understand it. Try and make sure it's good enough, well documented enough so that anyone could penetrate it, rather than necessarily relying on reams and reams of documentation. Code is unambiguous, documentation is ambiguous. So now I will. I'm not sure if anyone used Apache Zeppelin or any notebooks in general, like Jupyter or stuff like that. They're really good tools. These are off-the-shelf tools. They come with EMR. They come with HT Insights. You probably can just stop there. So software, yeah, like I said, it's going to be JVM. If you're going to be using Parquet, you're kind of committed to using Spark, because most other libraries just don't deal with Parquet very well. And don't really rate Python. I find that you find too many bugs which you find too late. One of the main problems with data engineering is that you take a long time to run your code, right? It takes hours to run your code. If you get a runtime error because you made a mistake and you've been running for 2 hours, that kills your dev cycle. Yes, you can use dynamically typed languages for tight code iteration cycles. If you're doing unit testing, TDD, got nothing against that. But in the big data world, that's just really slow. You need some extra stuff on top, and compilers are great. So this is just some pretty images of Zeppelin. This is the conclusion of the first half, which is around the definition of a data lake. And upskill, don't descale, code first. Now, this I want to give, a history of Spark. I guess I've been following it for quite a while. I started using Spark around here, so 0.7. And Spark, well, what was it? I want to give this overview because what it was originally invented for has slightly changed over time. And so I think the history is important as well as just what's going on right now. Before Spark, we had Hadoop MapReduce. And this was problematic. The interface was very, what's the word? Simple. You just had bytes in, bytes out kind of thing. It was map and reduce. Spark gave us a functional typed Scala API in the form of RDDs. In-memory caching, we didn't have that with Hadoop. There wasn't an easy way to do that out of the box. Broadcast variables, this is a way of sort of copying some data across all of the nodes. It's like a cache. For example, you could use that for a broadcast join if you've got one data set that's considerably smaller than the other. And these are things which would kind of difficult or would require hundreds of lines of code in Hadoop. So that's the reason why this thing was invented, okay? And then we had, then they added a Java API, which is great, anticipating Scala and Java interop. Just a question, how many people actually code in Scala? Is this entirely JVM? Anyone Scala? Okay, so at least third, I think. They added some more stuff to it. So Spark streaming, which wasn't really streaming. Python API, which I thought was, yeah, there's a lot of other things they could have focused on. Then they started getting some money by version 0.8. And then there was these sort of like hype years where they just went crazy with adding stuff, a lot of stuff, but kind of ignoring some of the fundamental problems. Now, so when it started, it was an open source project. It was solving a real problem. And I think what happened is that they got slightly sidetracked for trying to market Spark to the masses. So they added Spark SQL, which allows you to write SQL and it translates into Spark with really quite not very good optimization, lots of bugs, and it's kind of still pretty bad. And yeah, because you can, if you're monetizing something, you want to sell it to more people. So be wary of that and be mindful of that when you're dealing with the Spark APIs. Some of it is really good and really solid. Some of it is a bit flaky. And yeah, anyway, so this is when, yeah, I remember back we asked for RDDs to be covariant. Does anyone not know what covariant means? Good. So next, they brought out datasets API. This is a great improvement on the data frames API because this was using just string literals. Sort of like something which engineers have always considered pretty criminal is just developing an API entirely based on largely on string literals and no types. So they added types, which is a good thing, but the API is not as functional anymore. It's still quite declarative. For example, just a normal map operation is no longer a datasets thing. You know, MapReduce, you can't even do a map. So that's made the API a bit worse. You couldn't inject your own custom serialization, which is useful when you're trying to optimize things, heavily optimize things. Got a couple of minutes left. So, yeah, and then they introduced structured streaming API, realizing that the Spark streaming API was not very good. It was marked as experimental. It's pretty much deprecated now, so don't use it. But the problem is they reused their datasets API for structured streaming. So there's a lot of operations that no longer make any semantic sense. Like cache will just throw an exception. It says, no, you're not allowed to do that because this is not a batch operation, this is a stream. Okay, map partitions doesn't really make any sense. What is a partition? Is it a file? It used to be a file. Now a partition is a Kafka partition. So yeah, it messes with the semantics, which is quite frustrating. So what I would recommend, I'll just, this is what I hope, these are the things I want them to do, and this is the things they never actually get around to doing. So I'll just quickly skip. So I've talked a bit about this. RDDs, really, really good API, but a lot of people say don't use them. I mean, yes, the serialization is bad, but if you can work out how to do serialization yourself, then it's not so bad. Or use datasets in some situations, it's not so bad. But avoid Spark SQL. Nice thing about RDDs is the MapReduce, what's actually happening under the hood is represented neatly by essentially two functions, map partitions and combined by key. You can kind of think of those as map and reduce, roughly speaking, and if you read the MapReduce paper, it maps it exactly, so you can now think, this is how my job is going to execute on the cluster. When you go to this world, datasets and data frames, you don't really know how it's going to actually execute on your cluster, so it becomes more like a magic or art rather than a science. Yeah, these are kind of buggy. You do find quite a few problems. Like in the last few months, I found a lot of problems with the high-level APIs that do the reading of data. So in RDD world, what you'd do is you'd read everything as binary, just as bytes, or as text files, or as just text lines, and then you'd use your own parser. You'd use your own JSON library, your own CSV library, and you'll deal with it. The out-of-the-box ones on datasets and data frames, they do have quite a few bugs. It takes the edge cases to find those bugs, the weird cases, the escaping and stuff like that. I guess this is pretty good. Frameless. So this is a lot of the benefits of datasets without this weird sort of string literals and weird declarative syntax. So you can use this syntax, and now you get a compile error if you try and access a field that doesn't exist, rather than a runtime error. You can inject your own serialization, which is great. There must be a way of doing it in Spark, but with datasets. But this is a really neat way of doing it. It's a very neat way of doing it. If you're familiar with Scala and you're familiar with the libraries like cats and Scala Z, it has a lot of integrations with these libraries. So you can start using very terse syntax, and you can start using sort of more functional concepts to organize your code. Consequently, you can unit test it better. It's going to be more stable. You can optimize it better, understand how it works. I'm not saying that this is going to replace Spark. I think that this isn't part of Spark. This is actually another project to do with type level, to do with cats. But it'd be awesome if it actually got absorbed into the main Apache project. And like I said, maybe this Kafka thing's going to really take off as well. Yeah, this tool I actually trust, Hoodie. I can believe it kind of works because Uber is a real company. And with a huge amount of data, they're not a vendor. Vendors don't actually have their own data, right? So when they work on open source projects, they're working on it with the motivation of making it marketable. When a company builds an open source project, like the original MapReduce or like this, they're building it with the intention of solving their real life problem. So bear these things in mind, bear these commercial and psychological aspects in mind when you're writing, when you're picking which library am I going to use, which framework am I going to use, which tooling am I going to use. Because they could save you a huge amount of time. Oh yeah, finally, one issue you have is serialization. So I've talked about this serialization being a performance bottleneck. But the other problem is that serialization kind of happens in an unpredictable way in Spark. And I've given a separate talk entirely devoted just on when serialization happens and how it happens and what the performance implications are. And also, you can often get exceptions thrown by your code complaining about not serializable exception. And a lot of this is down to the way that serialization happens through the lexical scope of your variables. So if you have a variable within an expression, a lambda expression, and that variable is actually instantiated outside, say declared outside, say a map function somewhere, say it's reading a file, or it's a connection to a database, then when you try and execute your job, it won't be able to serialize that variable necessarily, say it's a connection to a database. And it'll either throw an exception, or it will serialize it, and it's something you didn't actually need it to serialize. Maybe you just access the header, just the top element in the collection, or whatever it is. And that's down to, I guess, a design problem, and it's related to both Scala and Spark. It's not an easy problem to solve. It's not entirely Spark's fault or Scala's fault. And you still have bugs in the closure cleaner. So the closure cleaner is the thing that's supposed to try and not serialize things you don't need, but it's not perfect. So be wary of that. There was a project which was some way of trying to solve this using some way of declaring explicitly what variables will end up getting serialized, but it still hasn't taken off. But so you have to be aware of that. You have to be aware of how the closure works and what gets serialized. And so that's another big caveat that I'd like to point out. So I'll just go back to conclusion. So yeah, be wary of all the caveats. Be wary of the APIs, especially the ones that vendors want you to buy. And code first. Try and upskill, not deskill. And I think, yeah, that's about it. Thanks very much. Cheers.